well, if I could be with Elon Musk today, we'd shake hands and like, let's do this. Then...
Hello, everybody. Welcome to another episode of Becoming Multiplanetary on the Total Space Network. I'm AstroRoadie, and today we have with us...
I'm RichLB, also host here at Becoming Multiplanetary. And today we have joining us Miguel Gurrea, who is the designer and architect of Mars Direct 3. Recently gave an update presentation at the Mars Society Convention 2021 and is here to talk with us about Mars Direct 3 here today. How are you, Miguel?
Thank you. I'm glad to be here. Thanks for inviting me. I'm doing quite good.
Awesome. That's great to hear. So, without any further ado then, let's get right into it and start with our first question. Can you give us a brief overview? Because you've been on the show before, haven't you, talking about Mars Direct 3. So, since then, what has changed with Mars Direct 3? What have you changed in the design?
Well, first of all, I've done a few minor changes, but most important stuff is I've actually done the numbers behind it, because the first time it was after I presented the idea at the 2020 convention at the Mars Society.
Yep.
And I presented the idea, but there were very few numbers behind it. So basically I learned to do them myself. I learned as I went. And now I have a paper which doesn't yet have all the updates, because I've worked a bit since the last time. But yes, I've done the paper. I've also done some other calculations. For example, one of the main complaints I got from last year was that the people didn't like the idea of the mini starship. I'm going to call it the Caravel ship from now on, but it's basically the mini starship. And one of the things they thought was that having only one engine wasn't safe enough, especially for such a long mission, which was a very good point. So I've done two things on that regard. One, the Caravel has been heavily redesigned. It now has 6 smaller engines that will hopefully be the same as the ones being developed for the moon landings. So there's no extra development. The main idea is I think we need a smaller ship, which I explain in the newer presentations and the paper. But the idea is, let's make it as cheap to develop as possible, so as close to the hardware we have as possible. So yeah, I've had those 6 smaller engines for redundancy and safety. And also since then, I've done some other changes with the new tanks, because I always take a look to the criticism I get from each presentation. And this year I got one that was very good criticism, which is I hadn't taken into account the internal volume of the Caravel, or I should say I had taken it into account, but I didn't know what standard I should hold it to.
Right.
So I had some estimates on the internal volume, because I had not coordinated with the designer for the internal volume, so I had done some approximation myself, and I got something on the lines of 85 cubic meters of interior volume.
Okay, sure.
And I thought that was pretty good, since Dragon has something like 11. So I thought that was good. But then someone in the comments of one of the videos sent me a link to a paper done by NASA, which had done a study on precisely what the requirements would be for the interior volume of a ship that was going to be doing basically the exact same mission, a mission to Mars.
Sure.
For 6 people, which was what I intended. And they got to the figure of 220 something cubic meters.
Okay.
Which was significantly more than I got.
Yeah.
So I looked at ways to fix it, and the only way was, okay, either this is a complete destruction of my concept for the mini starship,
right,
or it surprised me, because if I'm not wrong, Subrin intended to make it even smaller than me. So I started coordinating with the animator again, Gustavo Igon. He's the one who has designed the mini starship. He's great to work with.
Awesome.
And we we created some modifications, which hopefully, I don't know if in the edit someone can put them on screen, but the idea is to have around the engine more tanks, because basically if you have the ship, you have up above the space for people, then you got the fuel, and then you got the engine. And the thing is, the size is limited by the volume of the Starship, the cargo volume the Starship can carry, because the Caravel ship goes inside of it.
Yes.
So the engine sticking out takes quite a bit of length, because it's a long engine, especially if you have the vacuum variant, which is longer. And that's volume that we lose. And all the volume around the engine, which we thought it could be diverted to cargo. Given that we're going to use mostly the Starship for cargo, the cargo on the Caravel is not very important.
Right.
So we thought of using that space to have kind of smaller tanks around there.
Yeah.
To have more fuel, and that means you need less space in the middle part of the ship for fuel, because you've got to store it in the lower part, which means that the part where the people are gets a bit bigger. We also stretched it just a little bit, and we got a ship that's a bit heavier, but we're putting less cargo mass into it, because Starship's just going to do the job. So that's not yet updated in the paper or the talk, but the ship has gotten a bit heavier and complex. And the other change I've done since last year is I've also done Mars Direct 3 without the Caravel.
Okay.
So many people thought it wasn't worth it to develop that smaller ship. I think it is worth it, and I make the point in the paper. It requires so many less launches that I think it's economically viable. And some of the safety options, I believe, are easier with this smaller ship. It also has a huge reduction in the energy needs and cargo needs. So I do believe it is worth it. But just in case SpaceX just doesn't want to do it, I have also done the same thing with only Starship, because the main thing of Mars Direct 3 is not the Caravel or mini Starship, but the whole architecture of how to do these missions so that they are safe.
Yeah.
Because that's one of the main focuses.
I was just going to have you clarify for some of our viewers that might not be very familiar with your project so far. Is Caravel more intended to go back and forth from Earth and land on Mars, or is it just mostly to land and get into orbit at Mars?
Well, that's a good question. Basically, the reason I think we need it is the second thing you mentioned, because, I mean, you could essentially take the Starship to Mars with people. Landing a Starship on Mars, if it works, is fine. The problem is with taking it back. So you can do it a lot more easily if you have a smaller ship and you also have the bigger ship for cargo. But since you're going to have that ship for taking people back to Earth, you can just use it to take people from Earth to Mars in the first place.
Coming back there, you said you'd made a design alteration earlier where you'd moved the tanks into possibly in and around the engine skirt area. Now, firstly, when I'm thinking about something like this, I'm thinking, okay, there is a tank with fuel next to an engine that is probably going to be firing. So obviously this tank is going to need some kind of insulation. Have you thought about any insulation on that tank, and how much mass does that add to the equation?
We have not thought about that. The idea of the design is we are not capable of designing the entire ship so that it's basically enough to just manufacture. But since the ship is built to operate in vacuum or near vacuum on Mars, heat transfer is limited, and the exhaust is not going to be going in the direction of the tanks.
Okay.
Also, there's going to be a decent amount of separation, not huge, but decent, especially given that it's vacuum between those tanks and the engine. So from the looks of it, it does not seem like that would be a problem, though there's always a chance that we're wrong, and a specialist might disagree. I welcome any specialists who disagree with any of what I'm proposing, because the idea is that it works, not that it works just in fantasy land.
Absolutely. And what we'll do as well in the description of the episode, can we also add some link or something where people can get in touch with you should they want to share their thoughts with you? Is that okay?
Yes, you can put my Twitter and also the paper, which I will say is, I think I will be able to update it in the same link. So if you're watching this in the future, in a few months, and I've already done the update, I think I can make it work in the same link. But yeah, you can contact me on Twitter. Twitter is the best way.
No worries. We'll include a section at the end where we can go through socials and stuff like that as well. Next question I want to ask you is, since your first bash at the paper and now, what exactly have you learned along the way? What did you learn how to do differently? Or even new skills you might have learned along the way?
Yeah, I would say between I had the idea and I did the paper. So mainly I was a bit insecure about my ability to actually do the math, because I thought that was kind of the work of an aerospace engineer. I like to work around concepts and ideas and plans, but I am not the kind of guy who loves doing the numbers and stuff. So there was a time where I was just, I would have liked to outsource that to someone else, but I finally came to the conclusion that I just got to do it myself. And it wasn't as hard as I thought it would be if I got the right formulas into an Excel file, and then the operations were not hard. The hard part is to think, what actually do I need to calculate? And once I have that, the calculations are usually quite easy. So I learned to do it myself, basically. And some of the guesses I'd taken were accurate, but some were not. So always got to make sure to do the numbers.
Yeah, this kind of thing it's always like a learning process. Like you start out with a concept and then you refine it down as you learn. Hey, we don't actually need a 500 foot solar panel. We can get away with a 300. So that saves us a bunch of mass. Or there are various things that you learn along the way as you refine things. So if we all keep in mind that things are in constant evolution, just like they are with, Starship, as we watch it down there in Boca Chica. What we see today is very different from Mark I from a couple of years ago. So, things change, things evolve.
Yeah, exactly. It's a bit of pulling it from the realm of fantasy towards the realm of reality, bit by bit.
Do you still plan on using a miniaturized Starship, the Caravel, or are there other options on the table? You kind of talked about that a little bit before, but maybe we can elaborate on that.
Yeah, I've done several improvements on the design to match the problems that I found along the way. I still believe it is the best way, but there are some things which I cannot know, which is how much would it actually cost to develop. My intuition is it's very similar to Starship. In fact, the main engine is the same, and the secondary engines should be the same as the ones designed for the lunar Starship. In fact, the Caravel could also work, I believe, better as a lunar lander than Starship, but that might be a bit late for SpaceX to change their minds on. But the main hardware is the same. The design is more or less the same. It's a bit shorter than Starship relative to its length and width, but the materials are also the same. But the manufacturing machinery could be different. That's something I cannot calculate or math my way out of. It's just there are some unknowns. Mm-hmm. But SpaceX has proven that they're very, very good at doing things cheaply. And with everything they've learned from Starship, it shouldn't be a big difference, I think. So it's not going to be very expensive. But as I said, yes, I've also included a version with only Starship. I basically think Mars Direct 3 has so much more to offer than the smaller ship that I don't want it to depend on the smaller ship for it to be taken seriously.
Yeah, that's a very smart move.
If Mars Direct 3.0 were to be executed today, how long would it be before we saw our first human outpost on Mars?
Well, if I could be with Elon Musk today, we'd shake hands and like, let's do this. Then, yeah, that's a bit in fantasy land still. So it depends on how many resources they could put into it. As again, there's some uncertainties in regards to how much it would cost and take to develop it and test it. But then we would also need to get in touch with other manufacturers or industries to develop the other things that are necessary, like the rovers and the machinery for ISRU and train the astronauts. There are basically many, many things to do. And it's just a matter of we need to get people to work on it, have the resources for them to work on it, and have them test it and build it until it's safe, and then assemble it into one. So that way it's hard to do an estimate because it depends on the funds, the public interest, and the politics, and all that stuff. But 10 years, more or less, I think, could work. Maybe a bit less. As I say, it depends on the urgency. It basically depends on the resources, the urgency, and a bit of luck.
How long has it actually been since you first started working on Mars Direct 3? Like, when was the first day that you started working on this?
Well, it was almost exactly 2 years ago. It was November 2019, when I thought of the idea. I had been a bit in touch with Dr. Subrin when he actually presented Mars Direct 2.0, which introduced the mini Starship, but he didn't elaborate too much on it. And I didn't quite like the idea, and so I was against it for a while. And then we met in the convention. We couldn't discuss it because there was no time. But then I got home. Well, I was studying by myself at that time in the UK, in Southampton. And I remember going to bed thinking about Mars Direct 2. And I was like, yeah, I don't like it because we lose the capacity of the bigger Starship for cargo. And the advantages are there, but it may not be worth it to develop. And then I started to have some ideas of how to actually make it worth it. And one came after the other. And I remember I was kind of in bed rolling around until 4 a.m. And I was like, I got it. And the next day I wrote it in a Word document, and I stored it there for quite some time. I didn't make any changes. And in August 2020, I saw that, well, it was a bit earlier probably, that the Mars Society was going to do an online convention, and they were looking for people to present at the convention, basically. Mm-hmm. So I thought, maybe I could do this. So I wrote the proposal, and I sent it, and they accepted it. So I had to start working on it, getting in touch with animators, and there were some changes done when I actually started working on it, and then I did the first presentation. Then I didn't touch too much on it until basically the same thing happened the next year. The Mars Society did another online convention, and I'm like, okay, I got to do the numbers this time, and I rushed it basically until the end. I presented it and did the paper, and then I've done a few changes, which I've already talked about. And that's basically it.
You were just talking a little bit about the 2021 presentation. Do you feel that the update and the presentation was well received?
I think it was. People recognized that there were some technical problems with the audio, and I had just finished the paper the previous day or that exact same day. So I didn't have time to practice the presentation. So I did have also some responsibility into it. There wasn't enough time to do a good presentation of Mars Direct 3 in 25 minutes, basically. Yeah. So watchers have to bear in mind that I had to go over some things very quickly. Mm-hmm. But if you can bear that, it's decent.
Have you received feedback from any notable people in the space industry regarding Mars Direct 3.0, for instance, Zubrin or Musk?
I wish I could contact Musk, but I have been in touch with Zubrin since I'm part of the Mars Society Spain, and we were going to organize the European convention for 2020 here in Spain. Unfortunately, COVID-19 came and that could not be possible. But I did ask him a few things when I was doing the paper, because I was basing it on a lot of work that he had done. He actually gave me permission to use the name for Mars Direct 3 in this case, which is great. I'm very thankful for that. But he has said it is interesting, and I think that's very positive, because he doesn't keep his mouth shut when it comes to criticizing things. I admire him. I actually admire him a lot on that front. If he sees a plan that he doesn't like, he's going to crush it, and that's great. So the fact that he said my plan is interesting and then did not make any criticism sounds promising. But I don't know if he's busy or maybe disinterested, but he doesn't show much interest lately. So I don't actually know what his actual thoughts are.
Does Mars Direct 3.0 have the capability to use alternative launch vehicles made by other rocket companies?
Well, yes and no. Basically, if you developed more or less equivalent hardware, then you could make some modifications on the numbers and maybe some of the procedures to make it work. But you would have to basically develop very similar hardware. So it's not like, oh, it can be done with Atlas V. No, no, it can't. But if someone were to develop hardware that is quite similar and could be adapted, then yes, Mars Direct 3 could be adapted. But I basically just done it for SpaceX, because at this time, there's no serious competition. So it makes the most sense to basically already target it at the most likely possible company.
Sure. So, in your paper, your update, you talk about various pieces of other hardware as well, which I find very interesting. Things like the rover, the Saboteur reactor, so on and so forth. Have you actually, now I know you've probably not given too much thought to it, but have you thought about who you'd like to see, or who you think would be good at fulfilling these parts of the mission? Any particular space companies out there?
I have thought about it. It's not very high priority at this time. Mm-hmm. I thought about, for example, the CO2 converters. I'd like to see more than one company develop stuff so that there's some competition. Dr. Subin has a company called Pioneer Astronautics. He has been quite interested in that specific piece of hardware. And then there's another company, which I don't remember the name of, but one of the papers I read and I actually sourced it in the paper was the paper done by the people who developed the MOXIE experiment for the Perseverance rover, which is manufacturing oxygen from Martian CO2. And they list, they've been working with industry to estimate the design for that kind of machinery, but on a larger scale, and they have some estimates already there. And I believe they mentioned a specific company, so that could work. But then regarding the rovers, whoever does it best, let it just be some sort of competition like NASA is doing now with all commercial operations, and whoever presents the best design and gives confidence that they're going to be able to do it, then let them just go ahead and do it.
Mm-hmm. And lastly, you mentioned in your update presentation that the astronaut safety is of the utmost paramount in this mission. Could you elaborate a little bit more on how in Mars Direct 3 you achieve this safety, and why is it so paramountly important to have astronaut safety on this mission?
Well, thank you for that question. That's at the core of Mars Direct 3. I'm going to take a bit to explain. Basically, the idea is, what if we fail? Because that's something that could happen. So, if the people on the mission die, well, first off, obviously, you've just killed a bunch of people, which is terrible. But the consequences are not just that, because many people are watching that launch. Let's remember what happened with the original moon landing. many people, basically the entire developed world, was watching as that happened. And it gave hope to so many people. There have been some studies on the societal impact that had, a wave of optimism on what humans can do. Hope that the future is going to be good. We can do it. Children inspired to learn science and actually dedicate their lives to improving the world on so many fronts. But what would have happened if all those people, all those children and young adults had seen as our beloved astronauts had died? Well, it could have done the opposite. It could have been a wave of pessimism, a loss of public support for the program, even the cancellation of the entire program. And who would attempt to land on the moon after that happened, and after the public had just seen the people die? That would have been terrible. Fortunately, it did not happen. But given that Mars is a lot harder, it's a lot harder, and the mission profile will have to be more complex, the odds of that happening are higher, especially if you have to rely on ISIU for the return fuel. So given that SpaceX currently, or at least what they're publicly disclosing, is that they intend on depending on digging ice for water from below the surface, there's so many things that could go wrong with that. The machinery could not work. The water could be contaminated with things that the filters could not do. The filters could fail, which is something that it's not too hard for it to happen. The rovers transporting it could fail. So many things could fail. Maybe there is not as much water as they need. The solar panels might fail because you need such a huge amount of solar panels to produce the energy necessary to produce the fuel, and those are covered in dust. So you either take even more solar panels to compensate for that, or you have to have the people constantly cleaning the damn solar panels. The wires might break. There's so many things that could go wrong, and I'm not just here giving you a wave of pessimism to say, so we cannot do it. Like, we cannot look the other way and assume that those things are not there. We have to plan for that in advance. So do we have to do this in a way that's going to be a lot more expensive for it to be safe? Well, if that were the case, then we'll have to make a choice. And depending on how many resources we would have to pick one or the other. We would have to pick a risk profile. But with the combination of the bigger Starship and a smaller vehicle, I believe we can do it without increasing the price significantly. In fact, the original plan has, if we use the Caravel, the smaller ship, 4 ships landing on Mars for the first mission, which is not huge. It's not huge. People who have not delved into these kind of missions have the same idea of the mission to the moon, like one ship going there, one ship going back. That's not the case. For any realistic mission to Mars, we need multiple ships, and 4 is quite a decent number. It's not huge by any means. And if you plan all the things that I've got planned, for example, the 2 first ships are uncrewed, so if they fail, the people are safe home. If they fail to produce fuel, people are safe home because they have not yet launched. So the fuel production is done before people arrive. And that can be done because it does not rely on mining water ice. I take advantage of 2 major things that make it possible to only rely on Martian CO2. CO2 is very easy to extract because it's everywhere. You can just have the machine stick to the ship. And basically, it's the gathering air from the atmosphere. That's easy, a lot easier compared to having to actually dig and find ice and refine it. So, 2 facts. One, the Raptor engine uses methalox, which is liquid methane and liquid oxygen, but only 22% of that is methane. And it's for methane production that you actually need to dig water to extract the hydrogen, and then use the hydrogen with the carbon from carbon dioxide to make the methane. So if you could get the methane there, you would not need to mine ice. You would only need to extract CO2 for the oxidizer.
Right, yeah.
Which is still 78%. So you're producing 78% of the fuel on your way there. But 22% of the return fuel is still a lot for a ship to carry. So if we have the bigger ship having to carry the methane for the return of the smaller ship, then it's much smaller of a burden on the mission to have it taken there.
Mm-hmm.
So given the appropriate margins and that stuff, it's like 40 to 45 tons of methane. I don't have the numbers on my mind right now, but it's on that order that a Starship would have to land on Mars for this to work. So this is a lot better. It's already adds a huge layer of safety. And then I won't go into all of the contingency plans, but this mission accounts for, obviously, the first 2 ships can crash because the people have not launched.
Yeah.
You would miss a launch window and have to do it again, but people will be safe. Then the crewed ship, obviously, if it explodes when the people die, there's no amount of planning that can stop that from happening. But even if it crashes and the people don't die, but it crashes, they could survive because they have the backup ship there and the means of being transported to the other base. They can survive on the ship that was launched in the first wave and come back in it, no problem. There's a redundancy for habitability there because they lived in the ships and they have to, and also for the return. And also, if the 4th ship crashes, that's the 4th ship is good for making the base and the ISRU for the future, which will rely on ice. Like I intend the astronauts to actually try to dig ice, because the future is making all of the propellant there. The idea is for their lives not to depend on that successful mining of ice in the first mission. So all of that would be lost if the 4th ship blows up, but they would still be able to come back to Earth safely. Then there are contingencies in case the ship lands far away, or if there are failures during launch and landing. There are tons of contingency plans that basically this plan is almost everything proof. Like the worst things can happen. This thing is going to work. Like even relying only on solar panels, I've designed this so that they would be able to survive a storm that's 1 month or even like I think 2 months or 3 months long dust storm. They could survive only using solar panels and still come back to Earth by having extra methors that they can burn for electricity production, which is kind of having a battery, something like that. So yeah, I've done many layers so that they still might die. It's not zero risk, but if you compare it to another mission profile, it's a lot safer. There are many layers of safety to try to make the best, to give the astronauts the best shot at actually making it back, which is hugely important, as I've said. Mm-hmm. So that's basically the core and the main idea for Mars Direct 3.
That's some pretty amazing stuff, and I was watching your update presentation myself. I actually quite enjoyed it. Thank you for coming along and giving us this update in person, Miguel. It's been great. Is there anything else you'd like to add?
Thank you for inviting me here. And I'd also like to tell the public that these people at Total Space Network are great guys. They've been helping me since day one with everything I've needed. They have put me in contact with people like the Angry Astronaut. Rich precisely is helping me a bit with revision for grammar and all this stuff. So I appreciate everything that they have done for me. So yeah, give them love in the comments. And subscribe if you haven't, because these people are great and they deserve it.
Speaking of subscribing, do you want to let everybody know where they can find you online?
Yes, thank you for the opportunity. So I have created a YouTube channel called Mars Direct 3. It should be the first channel that comes up, though. If you look on YouTube, Mars Direct 3, you'll see the presentations and that stuff. But yeah, you can find. Maybe you can put the link in the description for the YouTube channel. There, I have a section where I have uploaded the first talk, the one in 2020. I haven't yet re-uploaded the presentation for this year. You can find that in the channel of the Mars Society, because I want to do a presentation myself that is well done, and I have enough time to explain the whole thing.
Yeah.
And I will do that once I have finished the latest changes, which shouldn't be too far from happening, but I'm kind of busy with all the things. So sooner or later, it's going to come a full video explaining the whole thing. And then you can follow me on Twitter at whatever I don't know if they're going to be putting this on screen right now or in the description. But yeah, you'll be able to find me and I'll answer any questions.
You bet. Yeah, thank you so much for joining us. And, if you need help with anything, we're very team space. So, you need contact with other creators. If we have that, we happily will share that. If you need help with any of getting your presentation put together, we're happy to help with that. You've got a fantastic idea, and we just like to help. As being team space as we are, we love to help all sorts of different things. We're involved all over the place. So, thank you once again for joining us.
I would really appreciate the help for outreach once these later changes are done, to make it gather as much support as possible. And then maybe if the idea is good, then maybe I will have to do some more changes. But if the idea is good, maybe we can get it to the hands of SpaceX. So fingers crossed.
If we ever get Innsbrucker on here, we'll slip it in his back pocket to take back to headquarters.
Yeah, they'll trust his word immediately.
Yeah. Oh, John, what's this you brought us? Mars Direct 3.
Elon Musk
What's
is just
this thumb drive in my pocket? Where did this come from?
Innsbrucker in the back of everything.
Before we go, we do have Patreon set up for the channel, Total Space, on Patreon, and we'd love any support we can get on that, as well as we should have channel memberships active real soon here, so they might already be going. Take a look at that if you're interested in supporting us there. And, thank you so much for coming. This has been another episode on the Total Space Network for Becoming Multiplanetary.
Thank you and goodbye.
Goodbye, everyone. Thanks.